Okay, in the last video, we derived an identity for the hyperbolic sine of x plus y, and we started out with the basic definition, which got us to this step here, and once we looked at that, we realized it's not going to get us very far. So here we had to be a little bit creative, and we said, well, look at this term here. We've got an e to the x times an e to the y. Suppose that we had some more terms up here in the numerator. Suppose we had this term, e to the x, e to the minus y. Then when we added these two terms together, we'd have e to the x times e to the y plus e to the minus y. That would be a hyperbolic function. And of course, we just can't add terms in unless we also subtract them, so that we're adding a net of 0. So we tried adding and subtracting this term to the numerator and to see if that would get some hyperbolic functions into the equation, and it did, and we eventually got an identity for this. But then the question became, well, when we're taking this kind of creative step here, instead of doing it like this, suppose we had added and subtracted e to the y, e to the minus x. Would it still work out for us, or was this just entirely fortuitous? So we wanted to take some time in this video, add and subtract this term, and see if we can get the same identity. So here we have, I'm going to replace this with this. So we have plus e to the y, e to the minus x, minus e to the y, e to the minus x. So now, we don't need this hanging around anymore. And this will equal e to the x times e to the y plus e to the y times e to the minus x minus e to the y, e to the minus x, and then back to our original term, minus e to the minus x, e to the minus y, divided by 2. And here we can factor out e to the y. That will be e to the x plus e to the minus x divided by 2. And here we have two negative signs, so we'll say minus something over 2. And here we have e to the minus x that we can factor out. And then that will give us, we have a minus sign here, so both of these will be plus signs now. So we have e to the y plus e to the minus y. And this is x here. So here's a hyperbolic cosine and another hyperbolic cosine. So this will equal e to the y, the hyperbolic cosine of x, minus e to the minus x times the hyperbolic cosine of y. And no choice, we have to do what we did before then. Remember that this is the same as hyperbolic cosine of y plus the hyperbolic sine of y times this minus, and this is now hyperbolic cosine of x minus hyperbolic sine of x. We had this presented in our introduction video. and that's being multiplied by this. Okay, hyperbolic cosine of x and y minus, looks like there's going to be cancellations here, but let's write everything out. But this times this plus this product minus this product and here's a minus with a minus, will be plus this product. Okay, we multiplied everything out. We took the time to do that, and sure enough, there comes the cancellation. So we're going to get equals this plus and this is indeed identical to its trig counterpart, which is what we obtained in the last video. So it goes to show us that yes, when we're up here and we take this kind of creative step, it doesn't matter whether we add and subtract this term or whether we add and subtract this term. Either way, it works out for us. Okay, what we'll do in the next video then is see if we can derive an identity for the hyperbolic cosine of x plus y. So come back, join us for that, and we'll see how it goes.